Hi, morning, everyone. Okay, let's start the class. Can you see my slides and hear me clearly? Okay, good. Okay, so let's begin. What is that? So today we're going to do parameter estimation. Still on the method of parameter estimation. Still on the method of estimating population parameter estimation using a confidence interval, okay, or interval estimation. So in the first two classes, in the earlier classes, we did confidence interval for the measurement of parameter mean, okay? Specifically on single population mean, i.e. how to calculate, how to obtain an interval estimate for mu, for a single population mean mu. And also in yesterday's class, we looked at how to find an estimate for the difference when you have two different populations. Okay, so that is for the measurement of parameter mean, population mean. So today we're going to do another population parameter, finding the estimate or interval estimate for the population parameter proportion. And we're going to look at both single population proportion and difference of for the difference between two different two population proportions. Okay, right. So before we go further, I'd like you to remember, for proportion, it is important for you to understand the definition of the proportion. But proportion can be of any time. It depends on the characteristics that you're investigating on. So in general, what proportion means is just the ratio between the number of observations for a certain characteristics over the sample size of the, for example, if it's population, so it will be over the overall population size. And if you have a sample proportion, this means you have the number of elements for certain characteristics over the sample size of the sample size. So basically, kalau population proportion, you cannot see the slide. Can you all see this slide, or is it just go just now? Oh, you can't see the slide. Go, are you here? Tadi macam go keluar sekejap ni. Okay, alright. Okay, internet problem. Okay, okay, maybe. Yeah, sure. Okay, so for proportion, it's important for you to understand what's the characteristics of what is the interest of proportion that you are trying to find here. Okay, so so this is for population proportion and this is for P. So if it's population proportion, it will be over the population size, okay, correction, population size, and if it's for sample proportion, it will be over the sample size, okay? So similar to the confidence interval for population mean, similar to this, what you're trying to do is you want to find the limits in which you believe that the population proportion lies within this limit, which has a probability of 1 minus alpha. Okay, that's the definition of your population of your confidence interval. That means the likelihood that your population parameter, in this case is population proportion, lies between a limit of some lower limit and upper limit is going to be of a probability 1 minus alpha. So that's why you're trying to find 99% confident interval, 90% confident interval, because that's the belief of the likelihood that the parameter would lie between these two intervals. Okay. So what is your best bet of what is your best guess of where that interval might lie? So we know from our first two classes that we will use the best point estimate. So the best point estimate for pi is going to be from its sample, which is going to be p. Okay, but oh yeah, okay, so p. Recall also from your sampling distribution for proportion, because you're going to use this to get your interval, is that for a sampling distribution of proportion, if your n is large, then um, it can be approximated as normal, because proportion initially it is from a binomial character. Because for example, let's say you want to find the proportion of students who are wearing spectacles. So you have students who are wearing spectacles or no spectacles. So there are two possibilities there. So initially it is from a binomial distribution. Okay, but when you have a larger sample size, then it can be approximated to a normal distribution. Okay, so because of this, then you can derive, which I'm not going to show you here. Um, you will get this confidence interval for population proportion with the marginal error taking the form of the probability for the sampling distribution, which is z times your denominator. Z times your denominator will become your marginal error. This is your marginal error. Because we're taking and then because why this can be so, because when a p is normally distributed, therefore you have a symmetric equation, so therefore it is legit if you do a sample statistics plus minus some error. So that means your interval would lie around this p value based on this error that you're going to calculate. Okay, so p minus and p so p minus your marginal error and p plus a marginal error will give you the limits. Okay, this is the same story as we have discussed for the population mean, or the population confidence interval for population mean, or confidence interval for the population difference between two means. The concept is still the same. Why? Because your sampling distribution is from a normal distribution. Therefore, you can do p plus minus some values. So you know your new estimate here would lie somewhere around p. Okay, all right. So this is your confidence interval. Do you have any question? Is there? Oh, sorry, lupa. Okay. So your marginal error is supposed to be z times this denominator, right? But because your pi is unknown, so therefore you need to estimate your pi with a p. So that's why your interval here is a p rather than a pi. Okay. Any questions so far? Okay. So the concept is similar to confidence interval for the mean. Okay. Um, the difference is you have got different sample, different point estimate, because this is your best point estimate, and also you've got a different marginal, slightly different marginal error, but the form is still similar. That means you're going to take z times this. Okay, right? Okay, right. Let's look at an example. Example one, because okay, uh, just to note, for confident interval for single population mean, this is the only formula that that there that this is the only formula that you can use. Okay, unlike confidence interval for the mean or different between means, there are too many conditions that you have to look at, right? You have to look at the population variance, blah blah blah. But here it's just this. This is it. Okay, there's no more formula. So this is an easy peasy confidence interval. Doctor, is it one Z alpha over 2 or Z A alpha over 2? Alpha over 2 is a probability. Okay, alpha over 2 is a probability. Is a probability. Z alpha over 2 is a point on your Z distribution. Is a point. Um, then I'll just write down first corresponding to okay. So your question, Ali Imran, you're asking, is it Z alpha over 2 apa tu apa tu bracket alpha over 2 or Z alpha over 2. Okay. Alpha over 2 is a probability. Let me get you a apa nama dia? I think I've drawn this I've drawn this let me just check. I've drawn this picture over and over again. Let me just pick that up so that I can just paste it here. Ya mana? Dulu pula. Mana? Cuba, cuba. Ni. Copy that. Okay. Um, here, just to note that paste, 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 paste. Okay. This is what I mean by that. So alpha over 2 is the area here. This is your area of alpha. Because 1 minus alpha is your confidence interval. Alpha over 2 is the area. Kawasan Alpha over 2 is the kawasan. Kan area is the probability under the graph. Area pula. Probability is the area under the graph. So this is the probability alpha over 2. So the shaded area is the area of alpha over 2 because it's symmetric. Confidence interval is symmetric here. So 1 minus alpha, this is your confidence interval area. So this is alpha over 2, alpha over 2. Now Z alpha over 2 is this point here. This is the point on the line. This is just a point. So alpha over 2 because it corresponds to alpha over 2 here. If this is alpha, then this point here is going to be Z alpha. But for confidence interval, for two-sided confidence interval, this is going to be alpha over 2. If it's a one-sided, then it's going to be just alpha. Okay, so this is alpha, this is Z alpha for one-sided. So for two-sided confidence interval, it relates to this Z alpha over 2. So this is a point. Okay, Ali Imran, you get it? Okay, great. Okay. Okay. So some people call this a leg score because it's a point. Some people use apa tu term this as Z score or critical value on your Z distribution corresponding to the probability, okay, or Z score. Another term is called Z score. Another term use, sorry. Okay, let's look at the example. A random sample of 400 components were tested and 6.25% of the sample components fail to satisfy production specifications. So this is one of the character. This is so 6.25% relates to components that fail specs. Okay. The question asks, find a 90% confidence interval on the true proportion of components that fail to satisfy the specifications. So this is what you need to find, which is the 90% confidence on the true proportion. True proportion is relates to pi. Okay. So let me just do the animation here. Jap, jap, alamak, jap. So here, note that the question is asking for 90% confidence interval on the true proportion. So i.e. you want to know 90% CI for pi. Okay. So as I told you before, the definition of pi for for each question can be different. So this pi here reflects what? The interpretation of this pi reflects one that failed to satisfy the specification. So let's say this is your diagram for population sample. So here you need to define. I think it's very, I think it's going to be handy if you can write down the definition. So here pi means that the population proportion of components that fail to satisfy the specs. Okay. Okay, what are the information that's given to us? A sample of 400. Can you see? Here you have a sample size of quite a large portion, 400, and 6.25% of the sample components fail to satisfy. Again, you can see from the sentence here, it says it fails. So when you want to find your pi, it's important for you to get the right sample proportion. Because as you know, sample proportion can be of two kinds, success or failure. So in this case, it can be fail or not fail. Okay, so the fail is being given at 6.25%. So this P correspond to the pi. Okay, so it doesn't make sense if you use if you want to know pi of failing, but you're using a sample size from the ones that do not fail. So in this case, it tallies. You want to find the population portion of fail, and you get and you use the sample proportion that fails as well. Okay. Once you know that, you just plug in the values as so. Okay. So just a matter of plugging in values here, and you get your pen. Okay. Right. So easy peasy. So here, okay, the definition of the jawapan, of the solution is very important as well. So what does this mean? This means that 4.246%. So the so we believe at 90% confidence interval that the true pi, the true proportion that fails would lie somewhere around 4.26% and 8.24%. So now you have a range of values to indicate the proportion of components that fail to satisfy the specifications. Okay, 4.26 to 8.24 is quite large. 8.24 is quite a big value if you're if you're doing a mass production of some components and it fails, kan banyak kan juga. So 400, 8.24%. Let's say you're doing a mass production, the 8.24% is quite a large figure. Okay. All right. Okay. Are we clear on this? This is quite easy. Okay. Okay, I'm going to do a second example. Now, this second example is slightly different. A random sample of 200 diskettes were inspected and 17 defective components were inspected were found. This defective components expected. You don't inspect defective components. Okay, right. Random samples from the were inspected and 17 defective components were found. Okay, find a 95% confidence interval on the true proportion of non-defective diskettes. Okay, so okay, so here you have 95% comfortable for pi. So what's the definition of pi here? Definition of pi is what? Is proportion of non-defective. So we're interested in the non-defective. Okay. And from the sample, 200 diskettes were inspected and 17 defective. So in this case, I can't use this I can't use this estimate to use it to calculate my confidence interval. I need to find the non-defective rather than the defective. So here I would have some proportion of non-defective because this is what I'm interested in, non-defective. Okay, although it gives me the 17 defective, but I don't need this information to estimate my non-defective. So I need to have a non-defective scale. In this case, it's going to be 103 over 200. So that's 91.5% because my interest is to know the estimate for my non-defective diskettes. Okay, once you have that, then to make sure that you have the right character that you're trying to find and use that to calculate your confidence interval. Okay, right. Do you have any question? Response, please. Okay, right. So this would be a booby trap here. This question is a booby trap because apa benda it wants the non-defective but it gives you the defective. So you need to write ni. So Kenneth, can we write the answer in percentage or decimal points? Both are okay. But if you change it into a percentage, I mean, when you calculate, obviously it's going to be in decimal points, right? Um, so when you change that to a percentage, you just have to be careful. Okay. So both are correct. If you want to be safe, then yes, do a decimal points is fine. A decimal point is fine. Okay, Kenneth? All right. Okay, right. Okay, next. Okay, that's done for single population. As I told you, it's quite easy. That's the only formula that you use, but you just have to be careful on the definition of the proportion, a sample proportion and population proportion that you're going to use in your calculation. Okay, so next we're going to look at confidence interval for difference between two population. So if you have difference between two population proportions or population proportions, then naturally you will have two populations. Okay, each one of them would have its own population proportion, but we're not interested in that. We're interested in the difference. Okay, the difference. Therefore, it's same story. You want to find, you want to know what is the probability, what is the interval in which pi 1 minus pi 2 lies between two numbers or two limits is equals to 1 minus alpha. So you want to find these limits that satisfy this condition. Okay. Again, if you want to find that interval, you have to get the best value for that interval. So the best value would come from your sample estimate. So which is your best point estimate. So in this case, it's P1 minus P2. So you want to estimate the difference between population proportion, you just use the difference between the sample proportions. Okay. So if you look at, so again, it is a normal distribution. The sampling distribution for two populations is going to be apa nama dia? A normal distribution. So your marginal error to form your confidence interval is going to be of the form z times the denominator. But because you do not know the value of your pi, so you just use an estimate from the sample. Okay. So this is like, so the intuition behind the confidence interval for pi 1 minus pi 2, similar to the mean, uh, it, it just uses the best point estimate plus minus some number. Some number is your marginal error. Okay. So again, you just plug in the values. For example 3, at Teguh Plastic Factory, plastic parts are formed using two different injection molding machines. Two random samples, each of size 200, are chosen, and 5 defective parts are found in the sample from machine A, where 6 defective parts are found in sample from machine B. We've got two questions here. One, to construct 99% confidence interval on the difference in proportion of defective parts. B, is there a reason to believe that machine A produced a significant decrease in the proportion of defectives over machine B? Okay. Okay. So proportion punya question, confidence interval, is rich with that kind of question just now. I said it gives you different information, and also the second challenge for the kind of question like these, it will ask for interpretations of the interval. Okay, let's look at the first part first. Construct 99% confidence interval on the difference in proportions. This is quite straightforward. So let me just use an animation. So here you've got two machines, A and B, and then therefore you're taking samples from these machines, and these are the information that you will get. So for proportion for machine A, you're taking 200, and from these 200, you have a sample portion of defective of 2.5%. And for B, is 6%. Okay, proportion of defective. So therefore, you can just plug in the values as so. Okay. Now note that here I'm taking pi b minus pi a. Uh, if I do pi b minus pi a, therefore my sample estimate has to be b minus a. Okay. And the rest of the information follows. Okay, so in 99%, so this is alpha 0.01 divided by 2, you at is 0.005. Find this value from your statistics table, and you get this value here, and you get your interval. Okay. Now, question, can I use A minus B? Yes, you can use A minus B. If you use A minus B, pi A minus pi B, this would be A minus B. Okay. So again, here I'm using pi B minus pi A. So therefore, my estimate is PB minus PA. If I were to use pi A minus pi B, therefore here I would use PA minus PB. Okay, remember, whatever estimate you're going to use should correlate with the proportion that you want to find out. Okay, so will the answer be the same? No, naturally it won't be the same, because here you're looking at the difference between P minus A, but A minus B is A minus B is the interval for A minus B. Okay. However, the length of this error is going to be the same. So if you were to okay, so if you want to find pi A minus pi B, you get a jawapan which is the opposite, which is which is going to be minus 0.471 or 0.371. It's just a different interval value, but it has the same length of interval with different points. Okay, for so specifically for this question, it does not specify which interval that you want to find out. So it's okay if you want to do b minus a or a minus b. But if the question asks you specifically that they want to find the difference in proportion of a over b, say, then it has to be a minus b. Ataupun it will write pi a minus pi b, then you need to really find the confidence interval for pi a minus pi b. If it's asking for pi b minus a, then you really need to do this. But for a general question like this, both of the questions should be correct. Okay? Because it doesn't specify what difference of defective of or which machines over the other or over which machine. Okay, are we clear? Okay, good. Now, for B, it's based on interpretation. Okay, B, it says, is there a reason to believe? The reason to believe here should be based on your confidence interval, because when you construct your confidence interval, that is your belief, that is your conviction of where your parameter lies. Okay, so is there a reason to believe that machine A produced a significant decrease in the proportion of defectives of machine B? Why is this question asking that? Because if you look at the sample proportion, well, you see that the defective for machine A is slightly less than B. Okay, okay, but you're not going to base your answer on the sample. You're going to base your answer on the confidence interval that you have already constructed. Okay, because from here you know that I'm very sure only 1%, if I take many, many samples, only 1% of an error I would make to say that pi b minus pi a lies within this interval, because I really believe at 99%. 99% means that if I take this sample or another sample or another sample, I will still have this belief. Okay, so is there a reason to believe that machine A produced significant decrease in the proportion B? So to find whether it really decreased is going to be difficult. So what you can do is you can use this hujah. You can just use this apa tu hujah apa support. Okay, so this is your answer. Let's say this is b minus a. So b minus a is this. Therefore, what I mean by this is I have this, right? So this is pi b is this is a value of pi b minus a. This is also a value of pi b minus a. Okay, right. So in this case, if I want to know, so I'm going to do a what do you call that? Okay, number that proof by contradiction. Okay. Now, if I have so if I have this like value, would it be possible that so here means that A is producing more defective. Here is A is producing less defective. So still I can't know whether it has a significant decrease or or not. But I do know is that it has a zero here. If it has a zero here, that means pi b would be equals to pi a. So that would define the fact that it's going to have a significant decrease, because there's a possibility that it's going to be the same anyway. So therefore, A would not be more superior than B. So, so is there a reason to believe that machine A produce significant decrease in proportion B? So the answer would be no, no, because so I should have, so there's no reason to believe, because since pi b minus pi pi b is equal to pi a. So therefore, would not be more superior than b in producing significant decrease in the proportion of defectives. Okay. I should have asked you that question rather than give you the answer. Do you understand? Oh. What if the percentage is different? Um, can you give me an example? So, can you give me an example? With the percentage, so here is not 99%. Then you need to find if the percent you mean the percentage is different. Okay, so naturally it will affect the value of your solution. So the difference with 99% and 90, let's say it's 90%. Okay, so and let me just how do I do this? Okay, so just remember this. So how does it affect the 99% or 90%? So remember your interval 1 minus alpha is this value here. Copy that. Copy. So you have a think. You have a think. So let's say that is a good question. Actually, so let's say I have this. Oh, shoot. Why am I copying this? Yep. Mana ni? Wait, 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 wait. Where is it just now? Okay. Copy. Copy this one. Let's see lah. Mm. I'm just going to give an example of a single population mean. Okay. Effect of um, um, effect of um, 1 minus of the interval percentage. Okay. Percentage of confidence interval. So in so you need to understand the concept of confidence interval. So here, 1 minus alpha. So you would have like 1 minus alpha. So this is 1 minus alpha. Copy that. Mm. So 1 minus alpha percentage confidence interval is this value here. Okay? Where 1 minus alpha is here. If 99% confidence interval, so for example, if I have a 99% confidence interval, my solution is this. Copy that, paste that. So for example, if for example, 99% confidence interval for pi minus e is this, what is the value? What do you think would be the value of 90%? So here, example here, yeah. Copy that, copy that, paste that. So I have this, Let's say I have this. Oh, lemak. Let's say that this is just a number, Let's say this is just a number. Let's say this is just pi lah. Let's say this is just pi. example there. Example, let's say I've got 99% of interval is this interval here. Okay. How would it affect if I make it 90%? 90% means I'm going to have, if I have a 90, so 1 minus alpha is this area here. Okay, 1 minus alpha. So the bigger the area, that means I would have what? Uh, Here I would have a larger value of z alpha over 2, and here I've got a less value of minus z alpha over 2, correct? So that means it will affect my marginal error. So 99%, 90% would affect my marginal error. So I would have, so this, that means, what if I have different percentage of CI, it would generally affect here, here. Like basically, it will affect this figure here. It will affect this figure here. Actually, it's just going to affect this figure. This is going to be affected. Let us use a bigger arrow. The one that's going to affect it is this value, right? So therefore, so if I have, like for example, 99%, I'm going to have a different value here. 90%, I'm going to have a different value here. Okay. So naturally, if 99%, I've got, for example, here I've got 2.3, 2.3 something. So if 99% is 2.3, 90%, I'm going to make my confidence interval to be more narrow. So let's say this is my 90%. Copy that. Okay. So basically I'm going to have a narrower confidence interval. So this means that here I'm going to have a narrower confidence interval because it affects my value of z alpha over 2. So just imagine you've got, let's say this is a general one. Let's say copy paste. Let's say I have a 90% here. Let's say this is 99%. 9%. Okay. So if I have a 90%, copy that piece. I'm going to have a much smaller 90. 90. I'm going to have a smaller uh, ratio values here. Okay. So because this one, I'm going to get apa? 0 point. What is this? 99% is 0.05. Also going to be 0.005. But this one, I'm going to get, what's that? 1%, 1% bagi 2 is 0. Dia dapat apa? 90%, 10%, this is going to be 0.05. Am I right? 5, 5, 10, 5, 5 is 1. So here I'm going to have 0.05. 0, oh shoot, 0.05. And if you look into your stats table, it's going to be 0. This is going to be less than 2 point than this. So this is going to be 0.005. So here 0.05 is 2 point something, apa? 2.5576. So here I've, can somebody get me the value of this is this is 2.576. Can somebody get me the value of that 0.05? What's that? What's that 0.05? 1 point? 1.65. So this is 1.65. Okay. So so basically 99% a has a very large interval here. So my my point here will go uh, to go will go further down the line. But this is 1.65 is going to be here. Okay. It's okay, Aiman. Um, so basically the effect is you're going to have a narrower figure. So your interval here uh, would likely be smaller lah. It will likely be a smaller interval. You might get maybe, I don't know, 0.01 and 0.03 say. So it's going to be narrower. But for the question just now, will it still affect your answer? No, because zero is still going to be in there. Okay? I mean, just to answer Muhammad Ali question just now. So basically, um, to answer your question, what if the percentage is different? Well, if you intuitively, zero will still be for this question. If you have if you change 99% to, let's say, uh, to 90%, what you need to do is you need to calculate first what's going to be the apa tu the new interval. Okay, but if you do not want to find the interval, so intuitively you can measure it from this. So 99%, or maybe it's like, let's say you have 99.8%, say that means you check whether your zero is still within that interval. Okay ke? Faham ke? So Muhammad Ali question ni doesn't just apply to this kind of question. It can be applied to other confidence interval as well. That's one of the rare but favorite question by the people who's doing the finals or your test. They like to use that kind of question to ask to make you think, or what is the interpretation of your interval? What is the consequences of your interval value if you change your, for example, your percentage of confidence interval? Will A be more effective in 90% cases? That's what I said. If um, A will be more effective if, say, if zero is not in your interval, then then if zero is not in that interval in this case, therefore you can say that A could be more effective. But if zero is still in there, then it will be the same um hujah apa? Hujah apa benda? It's the same hujah. Somebody help me. What is hujah? It's the same um it will the same yeah, thank you. It will be the same argument. Okay? Madam, if answer is 0.0371, then the answer will be is yes. That's right. Okay, let's say the answer is all positive. Let's say the answer is all positive. Let's see. Let me see. If answer is all positive here, tapi if for this interval B minus A means that A is producing less defective. So therefore, A is a much better machine. Yeah. So you're right, Louis. Yes. So that means if A is because we know that the definition here is B minus A means that A is producing less defective. So if you have all positive values, therefore, yes, then A would produce a significant decrease. So the answer is yes. That's right. Thank you, Louise. Anyone else? Any more question? Right. Um, okay. Right. So that's it really for confidence interval for proportion. I'll leave you with these exercises. Um, I think the only way for you to really understand and grasp what I mean, confidence interval is like a no-brainer. Like you just plug in the values, blah blah blah. Okay, but you need to get the information correct. But you also need to understand the concept behind it. So question like these would um, would give you a leverage on understanding the concept of confidence interval. Okay, right. So by the way, let's say you forget or the formula, so you can have a look at the sampling distribution, the final formula sheet or your uh or your statistics table page 2. You would have a hint on what your interval would look like. Like here, you can see this formula relates to this because you're gonna the marginal error takes the form of z times pi, tapi but you do not know pi, you just replace with p. So that would be your confidence interval. Similar to this, you can just have a look at this equation here, and apa tu you can form the confidence interval for the difference between two population proportion. Okay. Okay, sorry, okay. All right, a moment. All right, notice what if the question wants us to construct a different percentage of confidence? I mean, we need to repeat our process for the specific percentage using changing alpha. Question wants us to construct a different percentage of comfortable. Well, Muhammad Ali, so your question is wants us to construct. Okay, let's say the question asks you um, to normally the question of changing confidence different percentage, look at the marks of that question. If the marks say 1, say, then obviously you don't do the whole list of procedures. uh, you can think intuitively. Okay. um Moment, Ali, so it depends on the marks for that question. But if it helps you, do the whole procedure, tapi it will take you time. If the marks asking for change of percentage, and it's only like takes one or two marks, then I don't think there's any point for you to do the whole calculation. uh Normally they will ask, if you change the percentage, will you change um your answer in question B, say, and justify, say, something like that. So normally it just wants you to justify. Okay, Ali, George. So if both negative, answer is no. If both negative, let's look at here. If both were to be negative, for this is only for pi b minus a. So if pi b minus a, if it's both negative, so it's going that your answer will be on this end. So pi b minus negative value for pi b minus a means that a is producing more defective, right? So the total answer is surely no, because pi b minus a is a negative value. Therefore, uh, obviously, A is doing more poorly than B. Okay. Please note that it depends on all these answers that I'm giving to you is based on this example only. Okay, because this is B minus A. If you do A minus B, then it's a different story. So I suggest that when you get an interval like this, write down the interpretation. Then you'll be able to to answer the question as to what it wants. Okay, all right. Okay, that's it. All right. Alamak, pukul 10. Okay, okay, okay. I'm going off because I know that you might have class after this. Kejap eh. So I'll end the question there. So next week we're going to do the confidence interval for population variance. Okay, right. Uh, Open.